Welcome to Void Realities, a quiet space for those who cannot sleep. Here the mysteries of time, space, and the mind unfold like soft whispers in the dark. Let your thoughts drift, and let curiosity carry you deeper into the night. Why do stars twinkle? The silent sky above. Chapter summary. The night opens slowly as your eyes lift to a sky that seems both eternal and fleeting. Stars scatter like whispers, each one alive yet impossibly far. Here we begin with stillness, how the heavens seem fixed yet shimmer at the edges. The question of twinkling rests quietly, waiting to be explored. Full chapter body, 1,100 words. You step into the night and the world softens. The noise of the day thins into silence, leaving only the gentle rhythm of your own breath. Above you, the sky opens like a deep, endless ocean. It stretches without edges, without walls, carrying a kind of stillness that feels larger than you can hold. The longer you look, the more it seems the sky is not empty at all, but filled with tiny, trembling lights. At first you see them as scattered dots, as if someone had taken a handful of silver dust and let it fall across black velvet. But when your gaze lingers, you notice something else. The stars are not perfectly steady. They shimmer, as though each one flickers with a hidden breath, the faintest tremble, a living pulse. This twinkling is so familiar that you rarely question it. It has always been there, woven into your memory of night skies, the same in your childhood as it is now. It feels natural, inevitable, like stars are meant to sparkle, as if their beauty depends upon this trembling dance. Yet here, in the quiet, you allow yourself to wonder, why does a star not shine steady and calm? What is happening between you and the light that reaches your eye? The silence of the sky invites questions. When you look up, you are looking into time as much as into space. Each star is far beyond your grasp, far beyond the hills, the cities, the air that surrounds you. Many of these lights left their home long before you were born, before the world you know even formed as it is today. Some of the stars you see tonight might no longer exist, their fires extinguished ages ago, but their light still traveling across the void to greet you. In that sense, you are looking at history, at memories preserved as light. But still the light reaches you imperfectly. It trembles, not because the star itself is trembling, but because of the journey's final step. Between the vast silence of space and the quiet of your eye lies Earth's restless atmosphere. When you stand here and look up, the air that cradles your body is not still. Though you may not feel it on your skin, it moves constantly. Layers upon layers, rising and falling, shifting with heat and coolness, swelling and thinning like invisible tides. Light that has traveled for thousands or millions of years suddenly finds itself pulled through this ocean of moving air. Each time it bends, your eye perceives the smallest quiver. The twinkle is born in this restless breath of the earth. And yet, before we touch the science directly, you pause to simply take in the sensation of it. To lie beneath the stars is to feel small and infinite all at once. The stars ask nothing of you. They wait, patient, scattered across the darkness. You can imagine them as fires in the distance, as lanterns hung above, as reminders that the universe is vast and steady while your life is fleeting. It is in this moment that the human mind drifts naturally toward meaning. Ancient people looking up must have asked the same silent questions you ask now. Why do the stars flicker? What does their shimmer say about the heavens? To them, the sky was a living book, and twinkling was the language written on its pages. Some saw messages from gods, others saw warnings, others saw hope. Even now, with the language of science to guide you, there is still room for poetry. To know that starlight shimmers because of air does not take away its magic. Instead, it adds another layer of wonder. The beauty is in the fragility of the journey, that something so ancient can be altered in its last breath of travel. Imagine for a moment standing by the sea at twilight. The horizon glows faintly, and a lighthouse beam cuts across the waves. The light itself is steady, pure, but as it travels over the surface of the water, ripples bend and scatter it. From where you stand, the beam shimmers, breaks, reforms. The sea has transformed its appearance without changing the source. So it is with stars and air. The silence of the sky is deceptive, because silence is not stillness. Above you the air trembles and the stars appear to tremble with it. Yet you feel calm by this, not disturbed. The twinkle reminds you that perfection is not required for beauty. In fact, the imperfection, the flicker, the softness, is what makes the night sky alive. As you breathe, you notice how your own body mirrors the sky. Each inhale shifts your chest. Each exhale softens you back toward stillness. Just as stars quiver through the atmosphere, your own light, the rhythm of your being, moves through the shifting currents of breath and thought. There is harmony in this, the stars above, you below, both trembling softly, both alive in motion. You linger with this feeling, letting the thought rest inside you like a slow wave. You realize that the question of twinkling is not only a question of physics, but also a question of perception. The way you see the world is shaped by the medium through which you look. Just as air bends starlight, your own experiences bend the way you see life. The shimmer of the stars is both real and subjective, a truth of science and a truth of your own humanity. The silence deepens. You look at the stars again, and they seem more alive now, more present. Each shimmer is a reminder that the universe is not a painting on a ceiling, but a living relationship between you and the cosmos. The stars give their light, the air gives its motion, your eyes give their perception. Without any one of these, the twinkle would not exist. You rest in this understanding. The night sky no longer feels entirely silent, it feels like a gentle conversation. The stars whisper through their flicker and you listen. And yet the question still lingers, gentle but insistent. What is this light that has traveled so far? And how does it move across such distance to meet you here? If twinkling is the language of the atmosphere, then light itself must be the message. Light, the ancient traveler. Every beam of starlight begins long before you are born. It crosses space in patient silence, carrying the memory of its origin. Light is more than brightness. It is history unfolding across cosmic distance. In its long journey, nothing disturbs it until it touches Earth's air. You lift your gaze once more, and the stars seem to hold their breath with you. Their flickering is gentle, like candle flames trembling in some unseen draught. But beneath that shimmer lies something older, something more enduring than air. It is light itself, the traveler that carries the story of every star to your waiting eyes. Light is born in silence, deep inside a star's heart. There, unimaginable heat and pressure fuse atoms together, forging new elements, releasing energy in radiant streams. What you see tonight, the glimmer above, is not fire, though it may appear so. It is not flame licking through the void. It is something more ethereal. Packets of energy called photons, released in endless numbers, each one carrying a fragment of the star's essence. The journey of a single photon is almost impossible to imagine. Inside a star, it begins its life not near the surface, but buried deep in the furious core. Pressed by gravity and ignited by fusion, the photon fights its way outward. Yet the star is so dense that this outward path is anything but straight. The photon is absorbed, re-emitted, scattered countless times, bouncing from atom to atom in a dance of delay. What feels like a single moment to you may stretch into thousands, even millions of years within the star itself, before at last the photon escapes into open space. And then, freedom. Released, it begins a journey that is almost inconceivable in scale. The photon does not hesitate, it does not slow or tire. It moves always at the same pace, the cosmic speed limit, the speed of light. To cross 1 second of time is to cross nearly 300,000 kilometers, faster than your mind can truly hold. Across space it travels, unblinking, unbending, bearing the imprint of its star's creation. When you look up, you are not merely seeing points of brightness. You are receiving messages, each one written long ago. The nearest stars send light that began its journey years before tonight. The more distant stars, dozens, hundreds, thousands of light years away, send you light that began before your ancestors spoke the languages you know today. Some stars are so distant that their light left them when humanity itself had not yet walked the earth. To see a star, then, is to see the past. It is to hold history in your eyes, written in light. Imagine unrolling a long ribbon that stretches behind you farther than you could ever walk. Each star adds another ribbon, each photon a thread. The night sky is a tapestry of ancient messages, woven silently across eons. You are not looking at what is, you are looking at what was. Every twinkle above you is a glimpse into memory. And yet, across the immensity of space, light does not falter. It does not need to be carried or guided. It does not wander. Even after thousands or millions of years, a photon arrives unchanged, the same as when it left its source. Unlike the fragile objects of your daily life, letters that fade, voices that falter, light is faithful. It endures distance without decay, bearing its message intact. This endurance makes it both mysterious and comforting. For light is not only speed, it is also time itself, bound together with space in a fabric we call the universe. When you watch starlight, you are measuring distance in units of time, years of travel, centuries of persistence. The very word light year is not a measure of brightness at all, but a measure of how far a photon has walked in the silent darkness. 1 light year is nearly 10 trillion kilometers, and yet photons cover this distance as naturally as you breathe. Pause for a moment and think of your own scale of movement. A single step might cover less than a meter. A single day's walk might cover dozens of kilometers. A lifetime might take you across cities, continents, perhaps oceans. But a photon step is the vastness of space itself. While you mark your life in years and decades, light marks its journey in aeons. It is a traveler without fatigue, a pilgrim of the cosmos. Consider too that what you see is selective. Not all light reaches you. Some is absorbed by dust drifting between the stars. Some is scattered by clouds of gas, reshaped into glowing nebulae. But much of it slips through unimpeded, finding its way to the tiny circle of your pupil. That you, here on Earth, standing beneath your atmosphere, can receive such a signal is a quiet miracle of alignment. Out of the endless expanse of space, a photon finds you. You close your eyes for a moment, and you can almost imagine being the photon, born in fire, delayed by countless collisions, finally set free to cross the void. No hesitation, no distraction, just one direction, one journey, until the moment of arrival. And what is that arrival? It is transformation. The photon enters your eye where delicate cells respond with their own electric whispers, sending signals into your brain. That ancient light becomes vision, becomes awareness. You become its final resting place. This thought humbles you. Light has traveled longer than civilizations have existed, only to end its journey in the brief moment of your gaze. And tomorrow night it will do the same again, with new photons, new arrivals, each one completing its silent pilgrimage. But not all light is destined for your eyes. Much of it passes by unnoticed, striking no living witness. It travels still without purpose until it is absorbed by rock or dust or the faint glow of some other atmosphere. The universe is full of light that will never be seen, that will never be received. You then are part of a select circle, an observer, one who catches the rare gift of light's long journey. Yet even with this wonder, you begin to notice a question forming. If light is so steady, so faithful across distance, then why does it quiver when it reaches you? Why should a photon, unchanged after millennia, suddenly seem to tremble in its last instant of travel? The answer lies close to home, not in the stars, but in the air above your head. For space is silent and empty, but Earth is alive and moving. As light steps into your atmosphere, its perfect path is bent and shifted, pulled by currents you cannot see. You breathe, and you sense this truth, that the same air filling your lungs is the same air that makes the stars flicker. Light is the traveler, but air is the interpreter. Without air, the stars would shine still, steady, unwavering. With air, they sparkle like fireflies caught in a drifting breeze. The sky above seems calm, but it is in fact restless. The stars twinkle not because of their journey through space, but because of their final passage through this shifting veil of air. To understand twinkling, you must now turn your gaze downward, not into the ancient light, but into the living breath of Earth, the breath of the atmosphere. The air around you is never still. It moves like a restless ocean. Winds shift, temperatures change, invisible rivers of air flow above. This living breath bends light, pulling and stretching starlight in tiny waves. The twinkle is born from turbulence, an echo of air's ceaseless motion. You breathe in, and the air slips quietly into your lungs. You breathe out, and it leaves you again, unseen, unnoticed, yet utterly necessary. Air is so constant in your life that you rarely think of it. But above you, surrounding you, stretching miles upward, is an ocean of air in constant motion. The atmosphere is not still. It is alive. It shifts, it swirls, it breathes, and in its breathing it changes the way you see the stars. From the ground the night may seem calm. The branches of trees stand unmoving, the leaves barely stirred. You might believe the air itself is motionless. Yet above you, higher than you can feel, the atmosphere is alive with turbulence. Warm air rises, cool air sinks, layers of different temperatures slide past one another like invisible rivers. Winds whip, fold, and ripple. Think of a desert at sunset. As the ground cools, the air near the surface shimmers, wavering in waves you can see with your eyes. A distant horizon bends and blurs, as if the world itself has softened. This is refraction, the bending of light as it passes through shifting layers of air. What you see in the desert heat is the same principle that plays out above you every night, only on a grander scale. The atmosphere is made of layers, like veils stacked one upon the other. Closest to you is the troposphere, the realm of weather and wind. Above it, higher layers thin out into the edge of space. Each layer is shaped by temperature, humidity, and motion. Light from a star passes through them all, and with each layer its path bends slightly, like a beam of light bending through glass. But here the glass is uneven, rippling, constantly shifting. The word for this is turbulence, and it is the hidden sculptor of twinkling. Turbulence arises whenever air masses of different temperatures and pressures meet. Imagine a mountain stream. The water flows in waves, curling around rocks, breaking into eddies, always moving, never perfectly smooth. Air moves in much the same way, though you cannot see it. Invisible currents tumble and twist, creating pockets of warmer and cooler air that bend light in unpredictable ways. As starlight enters this restless ocean, each photon's path is nudged slightly differently. To your eye, the result is a trembling point of brightness, flickering as though alive. The twinkle you see is not the star itself shaking, but the shifting breath of the air between you and it. Pause and consider this. The atmosphere that gives you life also gives stars their sparkle. Without air, without turbulence, stars would appear steady, unmoving, their light a constant stream. In space, astronauts see stars as unwavering pinpricks of light. But here, wrapped in Earth's atmosphere, you are given a sky that sparkles as if each star has been set to music. You might think of the atmosphere as a great lens, but it is not polished or clear. It is more like water stirred by unseen hands. The surface ripples, distorts, bends. Drop a stone into a pond, and the circles spread outward, changing the way light reflects from the water. The star's twinkle is like those ripples, except you see them not on the water's surface, but in the air above your head. This turbulence is not uniform. On some nights the air above you is calm, and stars twinkle softly. almost lazily. On other nights, the atmosphere churns with restless energy, and the stars flicker furiously, flashing red and blue, shrinking and swelling. Sailors once relied on this, reading the twinkle of stars to forecast weather. A steady star might mean calm skies, while a flickering one might whisper of storms to come. Science, too, listens to the atmosphere's breath. Astronomers gazing through telescopes have always battled with turbulence, for even the most powerful lens cannot undo the restless shifting of air. To see clearly, they climb mountains, searching for thinner, calmer skies. They build observatories in deserts where the air is dry, or on islands where ocean winds smooth the turbulence. Still, the atmosphere is always there, bending, reshaping, twinkling. But beyond the scientist's tools lies your own experience. You have felt turbulence, though perhaps not thought of it in this way. You feel it when a plane shudders as it crosses invisible waves of air. You see it when heat rises from a road in summer, blurring the distance. You hear it in the rustle of leaves, the howl of wind around corners, the hush of air slipping through cracks at night. Turbulence is everywhere, weaving the world together. Now look again at the stars. Imagine each photon traveling straight, unbroken, until it enters this great ocean. Suddenly it is pulled slightly this way, slightly that. Multiply this by billions and you see the result. A star's steady fire transformed into a living, flickering jewel. The twinkle is turbulence made visible. And yet there is gentleness in this distortion. The twinkle does not destroy the light. It does not erase the message of the stars. It only reshapes it, bending it into a rhythm you can see. In this way, turbulence is not just chaos. It is also beauty. The air's restless breath paints the night with sparkle. You breathe deeply again, and the parallel becomes clear. Just as your own breath rises and falls, shifting with mood and moment, so too does the breath of the atmosphere. You inhale, and the air inside you is calm. You exhale, and it stirs again. The atmosphere is like a vast mirror of your own body, never truly still, always in quiet motion. To live is to move, and to move is to shimmer. This thought soothes you. The twinkle of stars is no flaw, no imperfection. It is a reminder that stillness is an illusion. Beneath apparent silence, the universe is always moving, always breathing. Even the sky above is alive with invisible currents, weaving their patterns in light. But as you rest with this understanding, another question begins to unfold. If turbulence bends starlight, how exactly does this bending create the flicker you see? What is it in the science of refraction, in the way light shifts through changing air, that gives rise to sparkle? To answer this, you must look closer at the dance between light and air itself, at how starlight, steady in space, becomes a trembling flame in your eye. A dance of refraction. Light bends as it passes through shifting layers of air. Each layer is like glass, uneven and alive with motion. Your eyes receive this bending as a flicker, a sparkle, a trembling flame. What seems like magic is a dance of physics, soft and ceaseless. You close your eyes for a moment and imagine starlight as a perfect straight arrow moving without pause across the emptiness of space. For so long its journey is unbroken. But the instant it touches Earth's atmosphere, everything changes. The air above you is layered, uneven, alive. Light, once steady, must now weave its way through shifting currents. In this weaving, the twinkle is born. This bending of light has a name, refraction. You have seen it before in everyday life. When you place a straw in a glass of water, it seems to bend at the surface. The straw is not broken, but light changes its path as it moves from one medium to another. Air and water are different densities, and light responds to those differences by shifting course. Refraction is this simple redirection, this bending of the path. Now imagine that instead of one surface, you have countless ones, layers of air stacked like invisible sheets, each slightly different in temperature and density. Starlight must pass through them all. Each layer nudges the light just a little, altering its direction, bending it this way and that. The path is no longer smooth but restless, wavering. By the time it reaches your eye, the star appears to flicker, as though trembling in place. This flickering is not random but rhythmic, shaped by the atmosphere's breath. Warm air rises, cooler air sinks, and the boundary between them is where the bending is strongest. Think of it as looking through a curtain of rippling water. The image behind it is not destroyed, but it dances and shimmers. The sky, it turns out, holds a similar curtain, always moving, never still. You can feel this principle in your own life. Think of the way heat rising from a road in summer makes the horizon waver. Buildings appear to shimmer, lines blur, colors flicker. What you see is not the object itself, but the bending of light in heated air. The stars twinkle for the same reason, though the scale is grander, the curtain higher above your head. There is a softness to this bending, a reminder that light is not rigid but pliant, like a dancer responding to the music of air. Each photon bends again, then straightens. To your eyes this becomes a sparkle, a flicker, a shifting flame. The star is steady in itself, but to you it appears alive, because the atmosphere has taught its light to dance. Consider how this connects you to the larger world. Every time you see a star flicker, you are witnessing a conversation between sky and light. The star gives its fire, steady and true. The atmosphere takes that fire and reshapes it, bending and breaking it, not to destroy it, but to transform it. What you see is not only the star, but the story of its meeting with Earth's restless air. Astronomers call this phenomenon scintillation, a word that itself shimmers. It comes from the Latin scintilla, meaning spark or glitter. To study twinkling scientifically is to measure the ever-changing refractive power of the atmosphere. Yet even in its scientific name, there is poetry. Scintillation, light trembling like a spark in darkness. And while you sit beneath the stars, this knowledge does not diminish the beauty but deepens it. Refraction is a reminder that you never see the universe directly. You see it through a veil, through the breath of your own world. The stars are steady. It is your atmosphere that makes them dance. You too live in such veils. Memory bends your experiences. Emotions bend your perceptions. What you see is always a mixture of truth and interpretation. The twinkle above you becomes a mirror of the twinkle within. There is also wonder in the sheer fragility of it. A photon has traveled unbroken for centuries, perhaps millennia. It has slipped through space unharmed, only to be bent in its final moments by something as soft as air. The gentlest turbulence, the faintest difference in temperature, and light wavers. What endurance and what vulnerability combined, strength across the cosmos, then yielding at the threshold of your sky. This vulnerability is part of the night's magic. Without refraction, stars would shine as unwavering points, precise but cold. With refraction, they become alive, their sparkle carrying the feeling of intimacy. The night sky is not only vast and distant, it is also close, touched by the air you breathe. Think of it another way. If you could rise above the atmosphere into orbit, the stars would lose their twinkle. They would shine steady and sharp, their light untouched by air. Astronauts describe this vision, stars like piercing diamonds, unblinking, unwavering. It is beautiful, yes, but different. Down here, you are given sparkle. The shimmer is Earth's gift to you, born of its own breathing. And so you rest under this trembling canopy, seeing not just stars, but the invisible life of air itself. Each flicker you witness is a signature of movement, a reminder that the sky is alive. The dance of refraction is ceaseless, quiet, endlessly repeated. It has been happening for as long as there has been air above Earth, and it will continue long after you have drifted into sleep. As you lie back, the thought eases through you. Everything bends. Light bends through air, rivers bend around stones, even time itself bends around mass. Nothing is perfectly straight, perfectly rigid. And in this bending, beauty emerges. The twinkle of the stars is not a flaw to correct, but a gift to cherish. But there is one more layer to the mystery. Sometimes as you watch, you notice the flicker is not only brightness but color, red, blue, gold, changing in the blink of an eye. This too is refraction, scattering light spectrum in its bending. The dance of refraction is not only about trembling flame, but also about color woven through motion. The colors that waver. Sometimes a star flashes red, then blue, then gold in the span of a breath. This is the prism of the atmosphere at work, scattering colors apart. Your vision catches the rainbow as it ripples through turbulence. The twinkle becomes a fleeting spectrum, a momentary jewel. Look again at the night sky. The stars still flicker, trembling softly. But now you notice something more. Their twinkle is not only in brightness, it is in color. A star that just moments ago seemed white now flashes red, then blue, then gold. The change is so quick you almost doubt it, as if your eyes are playing tricks. Yet it is real, born from the same dance of refraction that bends light into twinkling flame. The colors you see are part of light's secret. Though you may see starlight as white, it is in truth a mixture, a spectrum of colors blended together. Each photon carries a wavelength, and each wavelength corresponds to a hue. The long waves to red, the shorter to blue, the in-between to green, yellow, gold. Together they create the light you call white, a unity of many voices. But when starlight passes through Earth's atmosphere, that unity is sometimes broken. Turbulent air bends different wavelengths in slightly different ways. A layer of warmer air might nudge the blue light one direction, while cooler air bends the red another. To your eye, the result is a flash of color. The star seems to change its robe in an instant, flashing a new hue with every shift in the atmosphere. Think of a diamond held to sunlight. It appears white until you turn it, until the facets catch and scatter the light into a spray of rainbow sparks. The diamond itself is steady, unchanged, but the way light moves through it creates shifting color. The atmosphere acts like that diamond, though less polished, less steady. Each flicker of turbulence becomes a facet, scattering the star into a brief jewel. Some nights, when the air is restless, this effect is especially vivid. Stars near the horizon seem to shimmer wildly, flashing crimson and emerald, sapphire and gold. This is because their light must travel through more atmosphere when they sit low in the sky, passing obliquely through thicker layers of turbulent air. The longer path gives more opportunity for scattering, more chances for color to split and recombine. You may have noticed this yourself without knowing why. On certain nights, a bright star near the horizon may look almost like a tiny firework, flaring with hues that shift as quickly as your breath. This is the atmosphere's prism at play. It is the same principle that paints rainbows after rain. Sunlight, though white to your eye, contains every color of the visible spectrum. When it passes through raindrops, each droplet bends the wavelengths differently, scattering them into arcs of red, orange, yellow, green, blue, and violet. The rainbow is a gentle reminder that white light is not one color, but many. In the stars, you see this same truth, compressed into a flickering jewel, and yet not all stars shimmer with the same intensity of color. The brightness of the star, its altitude in the sky, and the steadiness of the air all shape how strong the flashes appear. Bright stars like Sirius often show dramatic color shifts, their brilliance scattered more vividly. Dimmer stars twinkle too, but their colors are fainter, less distinct. This play of color has long captured human imagination. Ancient stargazers, without the language of physics, still noticed the fiery hues of stars. Some described Sirius as blood red, others as flashing with many shades. To them, the shifting colors were signs, omens, messages written in the sky. Even today, poets speak of stars as gems in the heavens, borrowing the language of jewels to capture the sparkle of light broken into hues. But beneath the poetry lies science that is equally wondrous. The splitting of starlight is called dispersion. It is what happens when different wavelengths of light refract at slightly different angles. This is why a prism turns a beam of white light into a rainbow. The prism does not add color, it only reveals what was already there. The atmosphere, though imperfect, performs this same act, revealing the hidden spectrum inside the stars. Pause for a moment and let this thought settle. Every twinkle you see, every color that flashes for a fraction of a second, is not new. It has been waiting inside the light all along. The turbulence does not create it. It simply shows you what is already there. The star is always a rainbow. Your eye only sees it in pieces. There is a lesson in this too. So often the world around you appears as one thing, unified, steady, yet beneath the surface there is complexity, many voices blending into one. The twinkle of color is a reminder. What seems singular often contains multitudes. This scattering is also why stars near the horizon often appear redder. Their blue wavelengths are more easily scattered away by the long journey through the atmosphere, leaving red and orange to dominate. It is the same effect that makes sunsets blaze with crimson and gold. When you watch a star rise or set, you are seeing the same physics that paints the end of day. The star becomes a sunset jewel, colored by distance, by air, by scattering. Even the moon and planets share this to some degree. When low in the sky, the moon may appear orange, its light scattered just as starlight is. But planets, being larger disks of light, suffer less from twinkling, their broader beams less disturbed by turbulence, their colors shift more gently, less dramatically than the sharp points of stars. Astronomers, seeking clarity, often struggle with this rainbow. The colors they wish to measure are the true hues of the star, determined by its temperature and chemistry. But the atmosphere adds its own distortion, its own restless prism. To capture pure starlight, they must rise above the air, sending telescopes into space, where dispersion no longer scatters the view. But here, beneath the atmosphere, you are given a gift. The stars above are not static points, but living flames, trembling and flashing with color. It is as if each one is whispering a secret, showing you its hidden spectrum for just a heartbeat. You let your gaze linger on one bright star. For a moment it is white, then suddenly it flares red, then green, then blue. You cannot predict the next color, cannot hold it still. It is fleeting, like a jewel turning in the light, like a breath that cannot be captured. This fleetingness is what makes it beautiful. And as you breathe, you sense a parallel. Your own life too is a spectrum, many colors woven into one. At times one hue dominates, at times another, but together they form your light, your presence in the world. The stars remind you of this, that you are not singular, but many. You rest in this thought and the colors begin to blur again into white. Your eyes too blend the spectrum, seeing unity once more. The star steadies in your perception, though you know within it lies a rainbow. The flicker has shown you the truth. Beneath every steady glow is hidden variety, waiting to be revealed. And yet another question lingers softly. If stars can flicker with color, why do some lights in the sky refuse to twinkle at all? Why do planets, bright, steady, near, shine with calm even when the stars around them sparkle like restless fire? Planets that refuse to twinkle. Not every light in the sky trembles. Planets with their disks broader than stars shine with steady calm. Their light is spread wider, less disturbed by shifting air. Through them you learn contrast, stillness against flicker. The stars above you glitter like tiny jewels, each one flickering, flashing, trembling as the atmosphere bends their light. Yet as your eyes wander, you notice something different. Amid the sea of sparkling stars, a few lights shine steady. They glow with quiet calm, unwavering, as though immune to the restless breath of the sky. These are the planets, the wanderers of the heavens, and they refuse to twinkle. From the beginning of human history, people noticed this difference. Ancient stargazers gave the planets a name distinct from the fixed stars. They called them planets, meaning wanderers in Greek, because they moved across the night sky while the stars remained in place. But another difference was equally striking. While the stars flickered, the planets shone steady, like lamps suspended in darkness. Why is this so? The answer lies in size, in perspective, in the way light enters your eyes. A star, though immense in reality, is so far away that its light arrives as a single point. Even the largest star you see in the sky is no more than a pinpoint of brightness. This point-like nature makes starlight vulnerable. When turbulence bends its path, your eye sees the shift immediately. The tiniest disturbance makes the star tremble. A planet, by contrast, is much closer to you. Though still far by earthly measures, millions of kilometers away, their proximity makes them appear larger in the sky. Through your eye, a planet is not a pinprick, but a tiny disk of light. You may not resolve this disk without a telescope, but your eye still perceives its breadth. And this breadth makes a difference. As planetary light passes through the atmosphere, turbulence still bends it, just as it bends starlight. But because the planet's disk is larger, the bending is averaged across its surface. One part of the disk might flicker red, another might flicker blue, but together they blend into steadiness. The star quivers because its light is narrow, but the planet glows steadily because its light is broad. Think of it this way. Imagine holding a single candle flame in the wind. Even the smallest breeze makes it flicker wildly. Now imagine a lantern with many flames shielded by glass. The same breeze stirs, but the lantern's glow remains steady, its many lights blending into calm. Planets are like lanterns, stars are like candles. The difference is subtle yet profound. When you look into the sky, the stars remind you of delicacy, of fragility, of light that trembles at the gentlest touch. The planets remind you of endurance, of steadiness, of calm that persists even in turbulence. Together they balance the sky, sparkle and stillness side by side. This is why on nights when you are uncertain which bright light is a star and which is a planet, steadiness is your clue. If it flickers, it is a star. If it glows unwavering, it is most likely a planet. This simple observation has guided sky watchers for millennia, long before telescopes revealed their true nature. But steadiness does not mean dullness. Planets have their own beauty, their own secrets. Through a telescope, Jupiter reveals belts of clouds swirling across its vast surface, moons circling like a miniature solar system. Saturn shows rings so delicate they seem unreal, thin arcs of ice and stone dancing around a golden sphere. Venus blazes bright, sometimes so brilliant it casts shadows. Mars glows with a ruddy hue, whispering of deserts and dust storms. Each planet is a world, solid and real, unlike the distant stars whose light alone reaches you. And yet, you see them not as worlds, but as lights, lamps glowing steadily in the night. Their steadiness is soothing, like a heartbeat that does not falter. It gives the sky a rhythm, the twinkling scatter of stars, the calm glow of planets, each playing their part in the cosmic symphony. Astronomers, too, take comfort in this steadiness. While stars flicker and blur under turbulent air, planets provide reliable beacons. Navigators once used them to guide journeys across oceans. Astrologers charted their steady movements against the shifting constellations. Scientists, measuring their light, could study atmospheres, motions, and orbits, undisturbed by the twinkle that troubled the stars. The steadiness also makes planets seem closer, more approachable. Stars, with their flicker, remind you of distance, of fragility, of light traveling across unimaginable gulfs. Planets, with their steady glow, feel near, part of your own neighborhood in space. You can imagine walking there, sending machines there, someday perhaps traveling yourself. They are steady because they are reachable. And so the night sky divides itself into two truths. Stars shimmer with distance, planets glow with presence. One shows you the frailty of perception, the other shows you its resilience. One flickers because it is far, the other steadies because it is near. Pause and hold this balance in your thoughts. You need both. You need the trembling flame of stars to remind you of vastness, of the fragility of light, of the beauty of imperfection. You need the steady glow of planets to remind you of stability, of nearness, of worlds that wait within reach. The sky offers both gifts, both lessons, and as you breathe beneath this canopy, you realize something else. The planet's refusal to twinkle is not defiance but harmony. Their steadiness complements the stars' sparkle. Without one, the other would lose its meaning. Sparkle shines more brightly against calm. Calm feels more profound beside sparkle. The sky is a conversation between them, a balance of opposites. You linger in this awareness, letting the thought soften into stillness. Above you, the stars flicker, the planets shine, and together they create a night that feels alive and whole. You are part of that wholeness, breathing with the atmosphere that bends starlight, feeling the steadiness of your own heartbeat, matching the steadiness of the planets. But questions remain, as they always do. Why does the atmosphere bend light this way? Why do scientists, watching the same stars and planets, build tools to measure, to tame, to pierce the twinkle? How did they come to understand the difference between shimmer and steadiness? To answer, you must step into the mind of those who watched before you, scientists and sky watchers who turned curiosity into knowledge. For the twinkle of stars, the steadiness of planets, all became part of a greater question. How does the universe reveal itself through the air we breathe? The scientist's eye astronomers long ago noticed this trembling and asked why. They built tools, measured air, and compared what was seen. Science turned wonder into knowledge, yet wonder remained. To study twinkling is to study both Earth and the heavens. For most people, the twinkle of stars is simply beauty, something to enjoy, something to marvel at, something to fold into poetry and myth. But for the scientist, the twinkle was also a question. Why do the stars sparkle? What secret in the heavens makes them shimmer like tiny flames? The scientist's eye looks upward not only with awe but with curiosity, with the quiet hunger to understand. Centuries ago, long before the age of telescopes, observers of the night sky began to notice differences. The stars flickered, but the planets glowed steady. The sky was not uniform, it behaved in patterns. Careful minds began to ask, could this difference reveal something deeper about the world above? The ancient Greeks studied the heavens with remarkable patience. They recorded movements, traced patterns, and wondered at the restless sparkle of the stars. Aristotle himself suggested that the atmosphere was responsible, that layers of air, shifting and moving, bent the light. Though his explanation lacked the detail of modern science, he had already sensed the truth. The shimmer was not in the stars, but in the air between. Later, in the centuries of Islamic astronomy, scholars refined this knowledge. They built instruments, charted the heavens with precision, and studied the ways stars appeared under different skies. They knew the twinkle was not simply whimsy. It was a sign, an indicator of the state of the atmosphere. A star's flicker could hint at the weather to come. The heavens were not only distant, they were woven into earthly life. Then came the telescope. With glass lenses ground to delicate curves, humanity reached for clearer vision. Galileo lifted one of the first telescopes to the night sky, and suddenly the heavens unfolded. The moon revealed craters and mountains. Jupiter showed moons in orbit. Saturn displayed strange shapes that would later be known as rings. But still the stars twinkled, even through the telescope. The magnified view did not steady them. This puzzled astronomers. If the stars themselves flickered, then the telescope should have made their tremors clearer. But if the cause lay nearer, if it was in the air, then the telescope could not undo it. Over time, science confirmed what the philosophers suspected. Twinkling or scintillation came from Earth's atmosphere, not from the stars themselves. Each star was steady, its light constant. It was the turbulent breath of air above the Earth that bent and scattered the light, turning constancy into sparkle. The scientist's eye is patient. It is not content with answers alone. It seeks to measure, to map, to understand in detail. Modern astronomers developed ways to study the flicker itself. They measured how quickly a star twinkled, how much its brightness seemed to change, how its color wavered. From these patterns, they could infer the strength of turbulence in the upper atmosphere. In this way, the twinkle of stars became a kind of instrument, a tool to measure the air. Consider how remarkable this is. The stars are unimaginably distant, yet their trembling reveals truths about the thin layer of air around your own planet. To look outward is also to look inward. The scientist learns about Earth by watching the heavens, but there is more. The twinkle also became a challenge to overcome. For astronomers who wish to study stars in detail, to measure their brightness precisely, to see their planets, to analyze their light, twinkling was a distortion, a veil that blurred the view. The atmosphere, beautiful in its sparkle, was also an obstacle. The scientist's eye grew restless, asking, how can we see past the twinkle? Some climb mountains, building observatories on high peaks where the air is thinner, steadier. Others sailed to islands where ocean winds smooth the turbulence. The search for clarity became a pilgrimage, to seek skies where the stars twinkled less, where their light could be seen more purely. Even today, some of the world's greatest observatories rest on remote mountaintops, placed there because the atmosphere is calm, the twinkle subdued. Still, even the highest mountain cannot escape air. The stars still flicker, though less. And so the scientist's eye looked higher still, beyond the air entirely. With rockets and satellites, humanity lifted telescopes into space. There, above the atmosphere, the stars shine steady, pure, unshaken. The twinkle vanishes and light reveals itself without distortion. For the first time, the universe could be seen as it is, rather than through the trembling veil of air. Yet, curiously, even when the scientist removes the twinkle, the wonder remains. To see the stars sharp and steady from space is breathtaking, but it does not diminish the beauty of the twinkle seen from Earth. Instead, it deepens it. For now you understand what causes it, and you can see the atmosphere itself as alive, breathing, shaping your vision. Science does not take away mystery, it adds new layers of meaning. And so you rest with this thought. The twinkle of stars is both poetry and measurement, both beauty and science. It is a gift to the poet and a tool for the astronomer. It reminds you that wonder and knowledge are not opposites, but companions. To ask why does not end the mystery, it enriches it. The scientist's eye teaches patience. It shows you that even the smallest flicker can hold truth. To measure the trembling of starlight is to measure the breath of the planet, to glimpse the harmony between earth and sky. And as you gaze upward, you see yourself as part of this same harmony. A being who can wonder, who can question, who can measure, and yet still be moved by beauty. But the story is not finished. If the twinkle reveals the atmosphere, what happens when you rise above it? What is the view when the veil is lifted and the stars no longer tremble? To answer, you must journey beyond the breath of air into the stillness above the sky. Stillness above the air. High above the atmosphere, twinkling disappears. Satellites and space telescopes see stars steady, pure, unwavering. Without air, light is direct, unbroken, like water flowing without ripples. From orbit, the stars no longer dance, but glow with quiet truth. You close your eyes and imagine yourself rising, slowly, gently, leaving the ground behind. The air grows thinner, cooler as you ascend. The world falls away beneath you, and the vast blue sky deepens into indigo, then into black. At last you cross the boundary of air, and suddenly everything changes. The twinkling stops. Above the atmosphere, the stars no longer flicker. They shine steady and sharp, points of light that pierce the darkness with unwavering clarity. From orbit, the restless trembling you know so well has vanished, as though the stars have finally revealed their true selves. They no longer dance, they simply glow. The reason is simple. In space, there is no atmosphere, no turbulent currents to bend the path of light. Photons that have traveled for centuries or millennia now reach your eye unbroken, their journey complete. What you see is purity, a straight line from star to vision. The twinkle so familiar from Earth was never in the star, it was always in the air. Without that air, the stars appear as they are, steady, calm, eternal. Astronauts often speak of this moment with awe. The first time they see the night sky from space, they describe it as almost overwhelming. Stars appear brighter, sharper, more numerous. The blackness of space is not empty but rich, filled with points of light that feel closer, more immediate. Without twinkling, there is a kind of stillness, as though the universe itself has paused to let you look directly into its heart. Think of a river flowing in sunlight. On Earth, when you watch its reflection, the surface sparkles and dances. The light is scattered by ripples broken into flashes. It is beautiful, but it is not the river itself. Now imagine diving beneath, where the water is still and the light comes down pure. In orbit, you are beneath the ripples of air, looking at light unbroken. The sparkle is gone, but in its place is truth. This is why astronomers dreamed of telescopes above the atmosphere. For centuries, the twinkle was both beauty and frustration, a veil that blurred the sharpness of vision. When the Hubble Space Telescope was launched into orbit, the difference was astonishing. For the first time, humanity could see galaxies, nebulae, and stars with clarity untouched by air. Images that once shimmered indistinctly now revealed fine detail: spiral arms of galaxies, filaments of glowing gas, newborn stars wrapped in clouds of dust. The absence of twinkle gave birth to a new era of discovery. And yet, as you float in this stillness, you realize something deeper. Twinkling is not the true state of stars, but it is the true state of your relationship with them from Earth. The atmosphere is part of your world, part of your body's breath, part of your seeing. To remove it is to see clearly, but also to lose a familiar intimacy. From space the stars are pure. From Earth they are alive. Both are truths. This stillness above the air teaches you about perspective. What you see is not only the object but the medium between you and it. On Earth the medium is atmosphere, restless and alive. In space, the medium is emptiness, silent and still. Neither view is false, both are pieces of the same reality. The twinkle shows you the air, the stillness shows you the star. You let this thought linger. How much of your life is shaped by the medium through which you see it? Just as atmosphere bends light, memory bends perception, emotion bends judgment, culture bends meaning. To see clearly is not to remove these veils, but to understand them. Above the air you glimpse one truth. Within the air, another. Both matter. The silence of orbit deepens this reflection. Without air there is no sound. Your breath is contained within your suit, your heartbeat the only rhythm you hear. The stars shine steady, but they do not speak. The universe seems vast, remote, unreachable. Yet in this silence there is peace. The steadiness of the stars feels like a promise that beyond turbulence, beyond distortion, there is clarity. Still, the human spirit is restless. Even here, above the air, the scientist seeks to learn more. Space telescopes are built not only to escape twinkle, but to see what Earth's atmosphere blocks entirely. Much of the light from the universe never reaches the ground at all. Infrared light, ultraviolet light, X-rays, gamma rays, these are absorbed by air. Only in space can telescopes see them, revealing galaxies forming, black holes feeding, the cosmic microwave background left from the birth of the universe. In this way, the stillness above the air is not only aesthetic but essential. It opens windows closed to you on Earth. It lets you see not only stars as they are, but the universe as a whole. Each wavelength is a language, and space is the place where you can hear them all. And yet, despite this clarity, you feel a kind of longing. The twinkle is gone, and with it a piece of the night's magic. The sparkle you knew on Earth was a conversation between you and your sky. Here, above the air, the stars speak directly, but the intimacy of shimmer is missing. You realize then both views are necessary. The twinkle roots you to earth, to breath, to turbulence and life. The stillness reminds you of vastness, of clarity, of the unchanging truth beyond. As you drift in imagination through this orbital stillness, another thought arises. If humanity can tame the twinkle by rising above it, can it also tame it while still on Earth? Can the scientists' ingenuity find ways to steady the stars without leaving the atmosphere? The question lingers, soft but insistent. The tools to tame the twinkle. On Earth, scientists do not surrender to turbulence. They build adaptive mirrors that shift in real time. Lasers create artificial stars, guiding telescopes to clarity. Human ingenuity learns to still the shimmer of the sky. You return in thought from the stillness of space to the restless air of Earth. The stars twinkle again, trembling in their familiar dance. For the poet, this shimmer is beauty. For the scientist, it is both beauty and barrier. To study the stars, to measure their light precisely, to see the worlds that circle them, this requires sharpness, steadiness, a way to pierce the turbulence. And so humanity set itself a challenge: to tame the twinkle. The first tools were simple: placement. Observatories were built on mountain tops where the air is thinner, where turbulence is gentler. A telescope high above the low, shifting layers of air sees stars more clearly than one near the sea. Deserts, islands, mountain ridges, these became sacred places of stargazing, chosen not for beauty alone but for steadiness of sky. The twinkle could not be ended, but it could be softened. Yet still, even at the highest peak, the atmosphere remained. Its breath could not be silenced. Scientists began to wonder, could they correct the distortion in real time? Could they, in effect, teach telescopes to breathe with the atmosphere, to bend in harmony with its shifting? The answer came with a new idea: adaptive optics. At its heart, the concept is both simple and astonishing. If the air bends starlight, then bend the mirror to match. Inside these telescopes are mirrors that are not fixed but flexible. They are thin, polished surfaces controlled by delicate actuators, tiny devices that can push and pull the mirror's shape hundreds of times per second. As the atmosphere shifts, the mirror shifts in response, undoing the distortion before the light reaches the eye or camera. The star that twinkles to your naked vision shines steady in the telescope's corrected sight. But how does the telescope know how to bend? How can it sense the invisible turbulence in real time? Here lies the second tool: guide stars. In the old days, astronomers would use bright stars near their target as references. By watching how that star flickered, they could measure the distortion and apply the correction to the mirror. But not every patch of sky has a bright star nearby, so scientists created their own. They turned to lasers, powerful beams of yellow light projected into the night. When aimed upward, these lasers excite atoms of sodium floating high in the atmosphere, left there by ancient meteors. The sodium glows, creating an artificial star, a glowing point of light that exists only for the telescope. This guide star flickers as the real stars do, but its behavior is measured instantly by sensors. The telescope reads this flicker, calculates the distortion, and reshapes its mirror to cancel it out. The result is clarity: stars steadied, galaxies revealed, worlds beyond brought into focus. Imagine the poetry of this act: humanity making stars of its own, not to rival the heavens, but to study them more faithfully. The laser star is not for wonder, but for guidance, a candle lit in the sky to teach the telescope how to see. With adaptive optics, the Earth's atmosphere is no longer an enemy of clarity, but a partner. Its turbulence is measured, its rhythm understood, its distortions cancelled in real time. What once blurred vision now becomes a pattern to follow, a motion to match. The results are extraordinary. Telescopes equipped with adaptive optics can now see details once thought impossible from the ground. Astronomers can watch storms swirl across Jupiter, trace the dance of stars around the black hole at the center of the Milky Way, and even detect faint exoplanets hidden in the glare of their suns. Each of these achievements was made possible by taming the twinkle, and yet the twinkle is not entirely erased. Adaptive optics can steady a telescope's view, but to the naked eye the stars still shimmer. To you lying on the grass at night, the sky will always flicker with life. The tools of science tame the twinkle not for poetry, but for precision. The shimmer remains for you to dream by. Still, there is beauty in the ingenuity itself. Consider how remarkable it is. Light travels unbroken for ages, only to falter in the last stretch through air. And humanity, fragile creatures bound to earth, builds tools to undo that falter, to restore the path. It is as if you take the hand of the photon and guide it gently past the turbulence, whispering, "Go straight, go true, let us see you clearly." This taming of Twinkle is part of a larger story, the human desire to know. Each time science encounters a veil, whether air, distance, or darkness, it finds ways to lift it, sometimes by rising above it, as with space telescopes, sometimes by adapting within it, as with adaptive optics, always by asking, always by reaching. And so, the stars that once seemed beyond reach are brought nearer. Their steadiness is restored not because the universe has changed, but because we have learned to see differently. The twinkle is no longer only a limit. It is a challenge met, a barrier turned into understanding. You rest with this thought. The tools of science do not remove beauty, they reshape it. The twinkle you see and the steadiness the telescope sees are two truths of the same sky. One is for wonder, the other for knowledge. Together, they deepen the mystery and the meaning. But now another layer emerges. For beyond science's quest to measure and correct lies the human heart's quest to feel. Twinkling, even tamed, remains a symbol. It is more than distortion. It is poetry, culture, story. To truly understand twinkling, you must step beyond instruments and equations into the realm where shimmer becomes metaphor, where the sky's trembling becomes part of our own language. Twinkling as poetry. Yet outside the scientist's lens, twinkling holds meaning. It is the shimmer of distance, the pulse of a living sky. Cultures wrote poems and myths from the sparkle of stars. What science explains, the soul continues to feel. Even as science builds mirrors and summons lasers to steady the stars, your eyes still see them shimmer. And in that shimmer lives something more than physics, something older, quieter, woven into the human spirit. For the twinkle of stars has always been more than light. It has been language, metaphor, poetry. Long before telescopes, long before the word refraction was spoken, people looked at the night sky and felt its tremble. They saw stars flicker like watchful eyes, like lanterns, like sparks from an unseen fire. The shimmer was not only a question to solve, but a message to interpret. It became myth, song, prayer. In many cultures, twinkling stars were thought to be alive. Some said they were spirits watching, blinking gently in the night. Others believed they were fires tended by ancestors, shimmering as the breath of the heavens. In desert lands, the twinkle was compared to heat mirages, signs that the sky itself was breathing. In colder places, it was seen as the crackle of a celestial hearth. Poets have long borrowed this image. A star that sparkles seems more alive than one that burns steady. It seems to pulse with feeling, to tremble with emotion. A steady star might symbolize permanence, but a twinkling one speaks of longing, fragility, presence that feels close and yet untouchable. To write of love, of distance, of memory, always the language of twinkling returns. Even in lullabies, stars are not steady points but flickering companions. A child falling asleep is told of stars that twinkle, that keep gentle watch. The word itself carries comfort. To twinkle is to soften brilliance, to make light approachable. A steady beam might feel cold, sharp, unyielding, but a twinkle feels kind, playful, human. The twinkle also carries a reminder of impermanence. It flashes, fades, returns, never quite the same, never still. Just as a candle flame trembles in the slightest breath, so do stars tremble in the breath of air. The shimmer reminds you that nothing is fixed, that even the most ancient lights shift with the living present. And yet, paradoxically, that impermanence gives comfort. For while the twinkle changes moment by moment, the stars themselves remain. They endure for millennia, steady in their existence, yet alive in your eyes with motion. They teach that constancy and change can coexist. The universe is both eternal and fleeting, both steady and trembling. Cultures wove twinkling into guidance. Sailors on dark seas read the sparkle of stars not only for navigation, but for weather. A star that flickered furiously near the horizon warned of storms. A steady glow promised calm. The twinkle became a voice of nature, carrying messages from air to ocean, from heaven to human. In literature, too, twinkling carries symbolic weight. A character who looks at stars and sees them sparkle often reflects on love, or hope, or dreams. A twinkling star is not only physics, but emotion. Something distant enough to remain mysterious, close enough to stir feeling. Even in modern times, with science at hand, we continue to describe eyes as twinkling when they shine with life, when they hold joy or mischief. The metaphor remains alive because the night sky planted it in us long ago. And perhaps that is the most important truth. Science can explain the shimmer, but poetry gives it meaning. To know that air bends light does not diminish the beauty, it deepens it. The twinkle becomes not just distortion, but a bridge between knowledge and wonder, between explanation and feeling. Pause here and look once more at the night sky. Each flicker is a reminder of your own shifting heart. Just as starlight trembles in the air, your own thoughts, your own emotions bend and shimmer in the turbulence of life. You are not steady flame, you are twinkling too. The sparkle above is mirrored within. This recognition brings a kind of peace. The stars do not apologize for twinkling, they simply do. And so you too need not apologize for trembling, for shifting, for being shaped by the currents around you. Twinkling is not imperfection, it is expression. The poet's eye then finds in the sky not only science but solace. Twinkling teaches you that distance does not mean absence, that fragility does not mean weakness. It is precisely because the stars shimmer that they feel alive, that they speak. A sky without twinkling would be precise, yes, but it would lack the softness that invites the heart to dream. And so you let the shimmer comfort you. You listen not to its explanation, but to its presence. You let the stars twinkle as they always have, knowing that people before you saw the same, and people after you will see it still. The twinkle ties you to humanity, across centuries, across cultures. It is a shared vision, a shared metaphor, a shared comfort. But another thought begins to rise. If twinkling lives not only in poetry but in you, if your very eye and breath shape how you see the stars, then the story of shimmer is also personal. It is not only in the air above, but in the body below. Your eye, your breath, the sky. The way you see stars is shaped by your own body. The lens of your eye, the stillness of your gaze, the rhythm of your breath. You too are part of this atmosphere, moving and alive. The twinkle is not just above, it is within you. You look up at the stars and they shimmer. You know now that air bends their light, that turbulence scatters their rays, that culture and poetry give them meaning. Yet another truth lies closer still. The stars you see are not only shaped by the sky above you, but by the body within you. Every twinkle you perceive passes through the lens of your own eye, through the rhythm of your own breath, through the living system that is you. Pause for a moment. Imagine the path of light. A photon leaves its star, travels across centuries of space, trembles in the atmosphere, and then enters your eye. It passes through your cornea, through the clear lens that bends it, through the fluid that fills your eye. It strikes the retina at the back, where delicate cells wait to catch it. Cones and rods, tiny detectors of light, respond with sparks of electricity, signals that flow into the nerves of your brain. What began as fire in a distant star becomes sensation, vision, awareness, and here too the light can shimmer. Your eye is not a perfect lens. The cornea can bend unevenly, the lens can stiffen with age, the fluids can scatter. Your vision is alive, not static. Every blink, every tiny movement of your eye shifts the way starlight falls upon your retina. The twinkle you see is part physics, part biology. You are not a passive observer, but an active participant in the shimmer of stars. Even your breath plays a role. As you inhale, your chest rises, your head shifts the smallest fraction. As you exhale, your body relaxes, your eyes settle again. These subtle motions move your gaze across the sky in tiny arcs, too small to notice, yet large enough to affect how starlight reaches you. Your breathing body adds its own rhythm to the flicker of light. And then there is the heartbeat. Each pulse sends a wave of blood through the vessels behind your eyes, slightly changing their shape, slightly altering the way photons are received. In laboratories, scientists can measure this, the faint pulsing of vision that matches the rhythm of the heart. You do not see it consciously, but it is there, folded into your perception. Even as you gaze upward, the stars shimmer not only because of the atmosphere, but because of the living pulse of you. This thought is humbling. The twinkle is not only out there, a phenomenon of distant stars and restless air. It is also in here, woven into your breath, your eye, your pulse. To see is not to receive passively, it is to interpret actively. Every flicker is shaped by your own living body. And yet there is beauty in this imperfection. If your eye were a flawless machine, if your breath and heartbeat did not shift your gaze, you might see the stars more steadily. But you would also lose something. The intimacy, the human quality of sight. The shimmer reminds you that perception is not mechanical but alive. The stars are steady in themselves, but to you they appear trembling because you too are trembling. Your life meets theirs in flicker. Consider too the way memory shapes vision. You look at the stars not only with eyes but with mind. You carry associations, emotions, stories. A star that twinkles brightly tonight may remind you of a night long ago, or of a voice or of a song. The shimmer is not only in your retina, it is in your heart. Science can measure the optics but not the memories woven into the act of seeing. This interplay between outer and inner perception is part of what makes starlight so powerful. You are not looking at the universe from outside. You are part of it, folded into it, perceiving it through your own breath and body. The twinkle above and the twinkle within are one. Imagine for a moment lying still, holding your breath, steadying your gaze. The stars may appear calmer, steadier, yet the moment you exhale, the flicker returns. Perfection is impossible and perhaps undesirable. For the twinkle is not error, but connection, the universe reminding you that you are alive, that you too move with invisible currents. This thought softens you. You realize that the twinkle is not something to overcome, but something to embrace. Just as adaptive optics tames the twinkle for science, your body preserves it for wonder. You see the stars as no machine does, but as a living being whose own rhythm merges with the skies. And so, when you watch the stars, you are also watching yourself. The shimmer you see is shaped by your own vision, your own physiology, your own breath. The sky becomes a mirror, reflecting not only light from the stars, but life from within you. The more you linger with this, the more intimate the connection becomes. A photon that began in the core of a star long before your birth now completes its journey inside you. It has crossed vast emptiness, endured turbulence, and now merges with your awareness. You are its final resting place, its witness, its interpreter. The twinkle is the universe arriving inside you, filtered by your own living presence. And in that realization, the boundary between self and sky begins to blur. You are not separate from the twinkle. You are part of it. Just as the atmosphere bends the star's light, your body bends it again. Just as turbulence stirs the air, your breath stirs your vision. The shimmer above is continuous with the shimmer within. You breathe and the stars tremble. You blink and they sparkle. You exist and they shine in the way that only you in this moment can see them. No other being in history will see exactly what you see tonight, through your own eyes with your own breath. The twinkle is both universal and personal, eternal and fleeting. This is the quiet gift of perception. Science tells you why the stars twinkle, but your body tells you how it feels. Together they weave meaning that neither alone could hold. The stars shimmer because of atmosphere, yes. They shimmer because of your eyes, yes. But they shimmer also because of your humanity, because you are alive to see them. And so, as you settle into stillness, you accept the shimmer as part of life. You let it comfort you. The stars twinkle above, and you twinkle within, and in that shared trembling you find connection. The night sky is not distant, it is intimate. It lives not only in the heavens, but in the body that sees them. Yet the question does not end here, for if you yourself shape the twinkle, then so too does every being who looks upward. What does it mean for humanity as a whole, for our shared story, that we see the stars this way? How has twinkling entered not only your body, but your culture, your history, your collective imagination? Stars and the human story. The twinkle of stars belongs not only to you, but to all who have looked up. Across centuries, cultures shaped myths, songs, and guidance from their shimmer. Twinkling became history's mirror, part science, part story. Through it, humanity learned both wonder and belonging. When you gaze at the stars tonight, you are not alone. Countless eyes across countless generations have looked up at the same sky and seen the same shimmer. The twinkle you notice is not only a part of your own vision shaped by your body and breath, it is also part of a shared human inheritance, a story written not just in science but in history, myth, and culture. From the earliest times, people stood beneath the heavens and wondered. To them, the stars were not distant suns, but lights placed there with purpose. Some cultures believed they were campfires of ancestors, flickering in the distance. Others saw them as divine eyes, blinking gently, watching over the living. The shimmer gave the stars personality, a sense of presence, as if the universe itself was awake and aware. Sailors on ancient seas trusted the twinkling sky as their map. Constellations guided them across waters where no land was visible. Yet they also knew that stars flickered differently depending on weather. A steady star meant calm seas. A restless, flashing one warned of storms. The twinkle became both compass and forecast, woven into survival itself. Farmers, too, looked upward. The shimmer of stars in certain seasons marked planting or harvest. Myths were born, tying celestial sparkle to earthly cycles. Twinkling was not background decoration. It was a signal, a calendar, a rhythm that connected the heavens to daily life. In stories, twinkling became language. Ancient Greek poets described stars as living flames. In Chinese tradition, their shimmer was seen as cosmic breath, the chi of heaven made visible. In indigenous North American tales, stars were dancing spirits, their twinkle the movement of their joy. Everywhere, across cultures, the trembling of light was given meaning. It was never just physics, it was always story. Even lullabies carry this legacy. When you hear the words "Twinkle, twinkle, little star," you are singing a song that stretches across generations, carrying with it the comfort of the night sky. The child does not ask about refraction nor dispersion. They simply listen, and the twinkle soothes them. The song teaches that stars sparkle, and in their sparkle is safety. Science and poetry intertwine without conflict. Later, as science advanced, humanity reinterpreted twinkling. No longer was it divine breath or ancestral fire. It became understood as turbulence, as refraction, as the living air bending light. And yet, the stories did not vanish. Even as telescopes revealed the steadiness of stars above the atmosphere, people continued to write of twinkling as metaphor. Lovers' eyes still twinkle, hopes still twinkle, dreams still twinkle. The shimmer remains a symbol of life and warmth. This duality, science on one side, story on the other, reveals something profound about humanity. You do not live by facts alone, nor by myths alone, but by the interplay between them. The twinkle is both distortion and meaning, both turbulence and poetry. To understand one is not to erase the other. Instead, together they deepen your sense of belonging to the cosmos. Consider this. Every human who has ever lived, every ancestor who ever looked upward, saw twinkling stars. Kings and shepherds, poets and scientists, children and elders, all watched the same shimmer. Though their explanations differed, the sight was shared. The twinkle is perhaps the most universal experience in human history, constant across time and place. In its flicker is unity. And still today, in cities filled with artificial lights, people look up and find comfort in the sparkle of stars that remain. Though dimmed by pollution, the shimmer is still there, waiting, reminding you of your place beneath the sky. It connects you backward to those who came before and outward to others around the world. Twinkling is both personal and collective. In this way, the twinkle has shaped not only myth and poetry, but identity. It reminds you that you are part of a story larger than yourself. Just as photons travel across time to reach your eyes, so do human stories travel across generations to reach your heart. The shimmer is a bridge carrying meaning across centuries. Pause now and let this awareness settle. You are lying beneath the same sky as countless ancestors. You are seeing the same flicker, shaped by the same atmosphere, softened by the same human eye. You are connected not only to the stars, but to all who have ever looked at them. The twinkle is a thread weaving you into the fabric of human history. And yet the story is not finished. Humanity continues to look upward, continues to weave new meaning. Scientists tame the twinkle with adaptive optics. Poets preserve it in song. Children learn it in lullabies. Astronauts lose it in orbit. Each perspective is a chapter in the larger story of light. Twinkling is not just in the stars. It is in the way we carry them within ourselves. The human story of twinkling is the story of wonder itself. The impulse to ask, the longing to explain, the comfort of metaphor, the persistence of beauty. Science answers the question why, but humanity continues to ask what does it mean? And in this asking, the stars continue to shine with both knowledge and mystery. You close your eyes and the shimmer lingers in your memory. You hear the echo of songs, the whisper of ancestors, the rhythm of science, the poetry of love. Twinkling is all of these at once. It belongs to you, to those before you, and to those yet to come. But as your mind drifts toward rest, one final thought appears. The stars shimmer not only in the sky and in humanity's story, but in the quiet place of dreams. Perhaps the twinkle does not end when your eyes close. Perhaps it continues, softer still, in the landscapes of sleep.